look at this question. Find the volume of the solid that that results from revolving the region enclosed by y equals to x and y equals to x squared. You can see that this question now, we are having two equation, but we are not given a boundary. So in this kind of question, you have to use the Washer's method. But regardless, you have to compress, you have to turn this to, like, you have to equate these two equations. That's the step. You equate this equation together to get your boundaries. So let's start. So solution. The first thing is that when you have two equations like this, equate them to each other. So let this one to be y, let this one to be y1, and let this one to be your y2. Alright, so what do we do? That will be y1 is equal to what? y2, which implies that x is equal to x squared. Then we are having what? X squared minus x is equal to 0. It's very, very easy. Okay? It becomes x squared minus x equals to 0. So x is common. X into x minus 1 is equal to 0. So at the end of the day, we are having x equals to 0. Alright? And what? X minus 1 equals to 0, which means that x is equals to 0, then x equals to 1. So we've gotten our boundary at is 0 less than equals to x less than equals to what? 1. So it is facing the x axis. It's obvious. So that's it. So now we're having two equations, alright? So using the what? Using the Washer's method, because we're having two equations. Now what that's going to be, v equals to integral of a to b for the x-axis, then r of x. Okay. So at this side, using the Washer's method, r of x all squared. Alright, then you have your pi. Okay, minus the small r, because you're having two r here, r of x all squared, then your pi. Alright, yes. So this is for the x-axis. Now let's solve the problem now. So our first y is y is equals to x. This is our first r of x. That's our first r of x. Yeah, is equals to this first y, which is x, and our second r of x is what? Is this second y. Alright, so which is what? X squared. Exactly. We will be getting a negative answer. We'll be getting a negative answer, but regardless, there are still ways you can still make this one to you. It doesn't matter. So we are getting there. So what happens? We're having what? V is equals to integral of 0 to 1. Okay, then x, if you substitute it, become x squared pi minus x raised to power what? 4. If you substitute 2 times 2 will be 4, and pi. Alright, so this is pi. So at this junction, you are having what? Yes. Alright, so you expand. You are going to expand this guy. You get, so but when we take this pi outside, then we have v equals to pi outside, integral of the 0 to 1, then x squared minus x raised to power 4. Alright, these two guys, we are going to integrate the definite integral. That's pi. Then we now have what? X raised to power 3 over 3 minus x raised to power 5 over what? 5. Then it's 0 to 1. So now let's solve the problem. Pi into what? Anywhere we see 1, you know now, that'll be 1. At the end of the day, 1 is power 3 over 3 minus 1 is power 5 over 5 minus into anywhere you see x, you put 0. 0 is power 3 over 3 minus 0 is power 5 over what? 5. You understand? So you now have pi into 1 is power 3 is 1. At 1 over 3 minus 1 is power 5 is 1. You understand? So this one is 0 automatically. 0 is power 3 is 0. 0 divided by 3 is 0. So everything there is 0. Alright. So now we are going to be having v equals to pi into our LCM here is 15. And this is going to be 5 minus 3. Isn't it? So width in tons is going to be 2 over what? Over 15 pi. Isn't it? Yes? Our SM is 15. Alright, so 2 over 15 pi units cube. So you can see this is clearly our answer. So we have satisfied the washer method. So if this is helpful, you can drop your comment in the comment section. So I'm going to be giving us assignments. Looking at this, the area enclosed by the curve y equals to sine x is revolved about the x-axis through 2 pi radians. Alright, find the volume of what? Of the solid of revolution. So it's very clear that this one is a sine graph, okay? So it's very easy. So what you need to do is, this is your graph, okay, guys? This is what? This is your graph. So 2 pi makes a complete revolution, like you know, that's 360. Pi is representing what? Pi is representing 180 degree, right? And 2 pi makes what? 1 rev. Right. So now, since we have the points to touch at 2 pi radian, it is passing through what? 2 pi. So we have it starting from 0. This a sine graph always start from this region. This is a sine graph. But we reach 2 pi. From here, this place is 0, this place is pi, and this place is what? 2 pi. So we are stopping our graph here. Alright guys. So this way we are going to be stopping the graph. So we can shade it if you like. So this is your graph for that illustration. Alright, so this is your x-axis. Alright, so our equation is what? Our equation given is y is equals to, our equation given is y equals to what? Equals to sine x, right? Sine x. So what do we could do? So it is obvious that our boundary is between 0 to 2 pi. So our boundary is set to what? 0 to what? 2 pi. Okay. So we are going to use the disk method obviously for this. So we are having just one equation. We are using the disk method. Alright. So using the what? The disk method. So our r of x here is what? Is our what? Y, which is equals to sine x, which implies that our r of x is equals to sine what? Sine x. Alright. So now our volume using the disk method is what? Integral of a to b r of x all squared dx. Alright. So that's v is equal to 0 to 2 pi. Then what is our r of x? Sine x all squared, right? Dx, which is v is equals to 0 to 2 pi. This is sine square what? Sine square x dx. So sine square x relatively is the same thing as what? Go back to your trig identity. It's the same as 1 minus cos square x Do we understand that? 1 minus cos square x. So because sin square x plus cos square x is equals to 1. So when you make your size of your formula, you have 1 minus cos square x. Alright? So at this point, so we can have that v is equal to, we are going to expand this integral 0 to 2 pi, then 1 dx minus 0 to 2 pi cos square x dx. Alright, so this one becomes v equals to what? If you integrate this one, we have x. Alright, so 0 to 2 pi minus this one. We are still going to expand this one further. You can't integrate it like this. So if you remember that this one is still the same thing as 1 minus cos 2x over 2. You agree with me that cos square x is the same thing as 1 minus cos 2x over 2. How? Do you remember that we have that sin square x plus cos square x is equals to 1, and sin square x equals to 1 minus what? Cos square x. You will also agree with me that if you imagine I have something like double angle x plus cos into bracket x plus x, it is the same thing as sin x square, that is sin x minus cos x. You will agree with me that way. So which is, if you expand it, that's cos 2x. This one is cos 2x actually. So I'm just trying to let you know that x plus x will give us 2x. So this one is going to be sin square x plus what? Cos square x. We now make signs of your formula here. You understand? Or if you, this one is, you know, this one is sin square x is equals to 1 minus cos square x, you can substitute it here. You are going to be having cos 2x is equals to 1 minus cos square x. Right? Okay. Coming cos square x. Have I not made any mistake? 1 minus. This is minus here. So if I substitute this one here, 1 minus cos square x minus cos square x, that is here. So this one becomes cos 2x equals to 1 minus 2 cos square x. We made cos square x of your formula. At the end of the day, I'm going to be having this. That will be 2 cos square x equals to 1 minus cos 2x divided by 2. So you'll be left with this one. So that is how I came about it. So in case you are asking how I knew that cos square x is also the same thing as 1 minus cos 2x. So we are still proceeding in our solution. So at this junction, we have v is equals to x 0 to 2 pi minus this one. You can now bring out the constants. We have 1 over 2 integral of 0 to 2 pi, then 1 minus cos what? 2x dx. Alright, no stress. So we're having what? X minus x of 0 to what? 2 pi minus 1 over 2. You are going to integrate this guy. So if you integrate this one, how do you go about this? Integral of 1 dx 0 to 2 pi minus integral of 0 to 2 pi. You expand it with this integration. Then cos what? Cos 2x, right? dx. Alright, so at this junction we have s minus okay, 0 to 2 pi minus 1 over 2. Integrate this one, that's x, right? Minus, if you integrate this one, it becomes, you know, if you integrate, normally if you differentiate cos x, you're going to have minus x. But if you integrate cos x here, you're going to have x sin x, not minus sin x. So that will be what? Sin 2x over 2 if you integrate this guy. Alright, so we're also having 0 to 2 pi. Alright, so you can now expand. You are now having v is equals to s minus x over 2. Notice that minus is plus what? sine 2x over 4. Then is 0 to what? 2 pi. No stress. Alright. So we are getting there. Sorry, there's a pi here. Something is missing. So there's supposed to be a pi here. So that pi is outside there, right here. So you must put it. So sorry, there's a pi. So now remember that a pi is following it from the start. According to the formula, there's a pi there. So the pi is following it. So I've inputted the pi back. Alright, so there's a pi here. There's a pi here. So now this place we now have that what? You now solve this completely. So you are going to be having pi minus pi over 2 plus sine 2 pi over 4. So alright, so this is what we are having. No, 2 pi, sorry. When you input this one is 4, it becomes 4 pi. I'm inputting this one here, it becomes 4 pi. This one is 4 pi, sorry. Is it 4? 2 pi. This is 2 pi. I've inputted this one here. This one is also 2 pi. So this is 0 is useless, so it's just going to be giving you 0. So there's no point. Alright, so we're having pi here. So v equals to what? This one cancel this. So we're having what? 2 pi minus pi plus what? Plus sine 4 pi over what? Over 4. Alright? We're having pi here. So this one is what? 2 pi minus pi is pi plus sine 4 pi over what? 4. Then we're having what? Pi here. Alright? So if we expand it, we are going to be having pi square. Okay. Alright, so or should we just find it direct? Okay, I'm coming. So let me get this. Let's see. Sine, this one is 360, right? So sine 90 is 1. Alright. Sine 180, you know it has to be what? Sine of 360. I think sine 360 should be 0. So this one is going to be plus pi sine 4 pi over 4. So this one becomes 0 because sine 360 is 0. I mean pi square unit cube is our answer.